Here's another one of those interesting videos that might provide you with enough information to design and build a home like this one. So let's go ahead and get started with our first part, where we will be taking a tour of the lower wall framing. And to kick things off, let's go ahead and get started with the front wall. Now, the first thing I want to point out about this wall is that the windows are not in proportion. You could move either one of the windows over and possibly center them in between the doors, or move this window here over a little bit to where you have the same measurement on each side over here. And I believe what I did here was centered this window in the stair landing. And you can get a better view of that if we take a look at the landing. You can see here where the edge of the landing provides us with the same measurement on each side. Another common thing that an architect or building designer might do. In a view of the master bedroom exterior walls here. And I'm going to go ahead and remove the building foundation every once in a while to provide us with a better view of the walls. So we are going to have a couple of posts throughout the wall framing, and this one here, I'm going to go ahead and provide you with a view of the floor framing. And the reason why we're going to need the post here to provide us with some support for the upper floor beams. And over here, we just added a few more studs. And in some cases, you might need to install a post underneath each one of the beams. And that won't be too difficult because the engineer is going to call out for a specific item and its location in the framing. So if we do run into a few more posts, you're going to have a pretty good idea why they're going to be there. And of course, our bay window, this is going to be in the bathroom. We're going to have a bathtub here, and a window that is going to come out at a 45-degree angle on each side, and each one of these walls, the walls on both sides here, should be the exact same size. Otherwise, it might look a little corny there. And if you notice on this side here, we are not going to have a large header. However, that is not going to be the case for the bay window in the dining room. And we will get to that in a little bit here. And of course, these headers will need to be rated to support the floor framing load above. So here, for example, looks like I have 4x4 headers, where those might work over here and over here, but over here we might need a 4x6 or even a 4x8. And I guess now would be a good time to point out that this video is not meant to provide you with structural lumber sizes that will work in your area. You will need to contact a structural engineer to provide you with that information. Let's go ahead and remove the floor and take a look at the back wall, where again we're going to have another bay window. And for those of you wondering what in the heck this is, in our bathroom we're going to have a sink here, and this will be a medicine cabinet. It will be a hole that will cut out of the drywall so that we can install a medicine cabinet later after the walls are finished and painted. Next up, let's go ahead and work our way down the back wall. You can see here where the interior walls will be intersecting into these channels right here. And of course, we will have a door here, probably a sliding glass door. And of course, another post to support another floor beam and another bay window. All three of the bay windows in this home will be the same size. And of course, another door. Exterior door. Next up, let's continue working our way around the building where we have a couple of more walls, along with another support post here and another channel for the interior wall to intersect into, along with another exterior door. And of course, both of these doors will exit onto the exterior deck. And then our next wall, and you can notice here that this one extends beyond the framing of this wall here, exterior here, interior here, to provide us with a nice structural connection here, something that you're always going to be looking for when you're framing walls. And of course, the larger header I was talking about, this header here will be supporting a floor beam, and in most cases will require double trimmers on each side, which could create a problem if we're trying to have everything work out with equal measurements between our windows here. So I didn't change this because it would have messed up my windows. And of course, the window in the kitchen, we're going to have a sink on the other side. And the rest of our dining room here. Let's go ahead and finish the exterior tour with the front wall where we started. And again, these walls here will be a little taller than the rest of the house. And we will go into more detail about that when we take a tour of the roof framing and the floor framing. And we have another long interior wall here that will divide up a few rooms. And a large post. This post here is going to be supporting a lot of weight and will definitely require some type of a structural footing underneath it. And of course, our channels here where we will be intersecting additional interior walls into this long wall. And in this long wall, we will have another supporting post along with a post over here that will be supporting floor beams above. Let's go ahead and take a look at the walls located in our master bathroom. And hopefully I'll get this right. We will have a closet over here, shower, and a toilet. So the toilet will have a door on it, little privacy. And we will need a supporting header for the opening into the shower to support the floor joist. Next up, let's head over to the entrance area. Remember, the front door is here. And our stairs are here. We're going to have a walk-through opening here, a closet, and a bathroom. And of course, a closet underneath the stairway. And the entrance will be here, dining room over here, kitchen over here, living room over here. And hopefully you're still with me on this. Let's go ahead and take a look at the framing here. And another opening with a double trimmer on each side. This right here will be supporting the floor above along with this one. And when I say that, we are going to have a beam running across the front that will support some of that weight also. And try to make sure when you're laying out your framing that your breaks, the wall framing breaks on the lower framing plates are at least 4 foot away from the breaks on the upper framing plates to provide us with a nice structural connection again for all of our upper wall framing plates. And the last walls that we will take a look at will be the wall for the laundry area along with one of our structural posts there. So we are going to have a washer and dryer over here. You could always have the washer and dryer over here if it would work. And the reason why we don't have any windows over here is because these are going to be full height cabinets going all the way across. And that might even be the case over here for some extra storage. And of course, even though I have it in my model, it doesn't mean that you need to do it in your model. Next up, let's take a look at the floor framing to provide you with a little more information about this type of construction, along with the locations of all of the floor beams and the floor joists. Now, we are using truss joists in this example, along with engineered lumber for all of our beams. And the manufacturers for the truss joists also will provide you with some type of a rim joist material. And as you will notice going through the video, I don't think I have one beam that is not full bearing or sitting completely on top of the wall. Sometimes you will have the beam set back a little bit and then have the rim joist go through. And most of the time, either one of those methods will work for most engineers. And in this video, I will not be going over every single connection for the beams or the joist, because you can always contact the product manufacturer for that information or your engineer. However, I will be providing you with close-ups and a little more information that I might have left out in the previous video. And one of those examples will be the double trimmers that I installed here, and I provided you with 2 different ways. Here we have a full-length trimmer along with a shorter trimmer. Over here we have 2 full-length trimmers. And of course the key point will be to have 2 of those trimmers on each side if you're supporting a heavy load, or even a post or something larger if the engineer needs it. And for those of you who are not familiar with my channel, these are only construction methods that might work. You might need to hire an engineer or contact your local building authorities for permits also. And all of the joists in this example will be 16 inches on center. And another thing I want to point out is that if I moved this wall over, I could make the beam shorter and probably go with a smaller beam if that would work for your particular project. And of course, this beam does need to be in this location to work structurally with the roof. So you're probably not going to have a choice of moving the beam back. However, you might be able to move the wall and have it sit under the beam, and then simply put a structural footing in the floor foundation to transfer that load down to the ground, like we have over here and over here. So you can get a pretty good idea how the beams are supported to create open spaces in the lower floor. Now, if we take a look at this beam here, it's basically going to tie into this beam to create some type of a structural drag in the same way that we will be using this beam here to connect the back of the house from the front of the house. We can use these beams here to connect one side of the house to the other side of the house. And by doing that, we can use some type of a strap to connect the beams together. And for those of you wondering why in the heck this gap is here, that's because this beam here is going to sit on top of the subflooring, and we can use a hanger to support this beam here, along with some straps to connect the beam to the supporting post. And this strap here will attach to the underside of the beam. And keep in mind that this is a small strap. You would probably need a much larger strap to connect the two beams together. So here we have a long drag structural connection that's going to make our engineer happy, along with our joist hangers, again, spacing 16 inches on center. And you might consider installing some web stiffeners. And there is definitely more information about web stiffeners at the product manufacturer's website and in their installation instructions. I highly recommend reading the truss joist, whatever joist you're going to be using, the product manufacturer's installation instructions if they have them. And of course, a view of how the rim joist is going to butt up against the beam. Again, the beam is full bearing sitting on top of the 3.5-inch wall, along with our ceiling backing here. Take a look here where we attached a 2x4 to the top of the wall framing so that we have some backing for our drywall, so we can attach it to this board. Otherwise, our drywall is just going to be flopping around in the air. So another thing you can consider doing on your project. And in some cases, we will need to position the blocks in a certain spot to work with our subflooring. And you can see here where the subflooring is sitting half or centered on top of the block, so that we can install the next subflooring to create a nice solid connection between the two floors or two sections of the floors. And I went ahead and ran these joists a little bit longer. I like doing this. However, you can always stop them here if that's going to work better for your project. And again, you can see here where we get a nice, clean, and smooth transition in these two sections where the subflooring, plywood, or OSB is switching directions. And of course, the plywood switches directions because the joists are switching directions. And here's another thing you might want to do, and that would be to extend the beam if you have a little bit extra to spare on the beam. If not, you could always stop the beam over here. If, for example, you had like a 14-foot beam and this is where the 14-foot section ended. And I've been doing it for years. There's no need to order longer lumber to make something like this work. Just simply run it past a little bit so that you can get a little more bearing on the walls. And you can see here where I would have a difficult time attaching the hanger to the top of the beam if I stopped it even with the edge of the wall here. And that might not be that big of a deal. You could just simply adjust the layout to compensate. And again, another view of the long structural connection from the front of the house to the back of the house. And basically, we're going to have something similar to it right here. And we're going to use another strap to connect the wall framing to the beam, along with some building hardware to connect the beams to the wall framing or even the other beams. And you can always use stronger connectors, and an engineer might actually call out for different connectors. Keep that in mind. And this beam will help tie this wall together so that we get a nicer connection between the sides here. Even though that is not going to be the case right here, our stairway is going to create a problem for a connection that's going to run all the way through. And of course that might require additional structural reinforcement. So again, the joist changing directions. And if you have extra lumber, you can butt the joist up against the other joist or stop it at the end of the wall. And of course, our ceiling backing again, we can use a 2x6 instead of two 2x4s here, if of course that will work for you. Everything in this video is just a suggested method of assembly. And if for your particular project it's going to work better to do something else, then I would say go for it. And with that said, if you have any suggestions about something that might work better, feel free to share those in the comment area. And again, we are going to use our blocks here to provide us with a change in the sheathing direction. And for the most part, this side is the same as the other side. And if you remember, on the other side, this beam was sitting on top of the bay window opening with the large header. And if you do run into a situation where we have the window over a little bit, and it's going to work out better for us to have a solid post under the beam instead of putting a huge header over the window opening with double trimmers, whatever the deal is, think about whatever the reason is. If it needs to stay there, leave it. But if not, sometimes you can simply move a window either to the right or the left of a structural post, a post support, if that's going to work better for your project also. And most truss joists will be fastened to the top framing plates with either 16D nails that might be commons or sinkers or even different sizes. Again, 16-inch on center layout. Another way that you can finish this section here would be to extend the rim joist and kind of use it as a block up to the next joist here. And again, that would be if the lumber lengths allow it. Same on the other side here. Now we have another bay window, 45-degree angle on the joist here. Let's go ahead and take a look at it from the outside. So we have our rim joist. Again, the beam is full bearing, post under it to provide us with a nice load transfer. 16-inch on center joist spacing that you're going to need to put some thought into if necessary. Keep in mind that some of these joists will need to be repositioned for a variety of different reasons: plumbing, heating, and in some cases even electrical. Next up, let's go ahead and install our floor sheathing. The direction of the floor sheathing is going to be running this way. Over here, it's going to be running this way. Remember, the joist switched directions there. And even though I cut this like this floor sheathing here can simply continue through. It doesn't need to break over here, and it would probably work better if it did continue through, especially if you're not going to have a problem with the stairway. And let's not forget that in this example here, we are going to need an overhang. We're going to need to extend the floor sheathing so that our tread overhang will work. We are going to have a 1-inch nosing or a 1-inch overhang for our stair treads. And that means we're going to need it up here also. And of course, you will need to switch directions here. Now, if you can see here, I don't have the floor sheathing breaking half on the joist or even half on the stringer. This isn't going to be a big deal because it's going to basically be supported by the stringer. And I doubt if anyone's ever going to put their foot over here. However, you can always break it on the joist. I will leave that up to you. So again, the floor sheathing here can continue all the way through if it's not going to create a problem for the stairs. Sometimes the floor sheathing will break over here and you'll need to add a block under the floor sheathing or reposition one of the stringers underneath the break. And if you did something like that incorrectly, you could end up with a squeak in the floor here. And of course, the floor sheathing switches directions only in this area here and the two areas in the front, or these sections here. So the grain of the plywood or the OSB is basically going to be running in this direction here, this direction here, this direction here, and it's going to switch in these two directions here. Next up, let's go ahead and take a look at the second floor wall framing. I'm going to go ahead and leave the floor framing in, get about halfway through the video, and then remove the floor framing, the wall framing below, and the foundation to provide you with a better view of the wall framing. And almost every wall in the video will have another wall that will be built exactly the same. And two of those walls will be this one and this one, where they will both be built on top of a beam with 2x6 wall framing studs and a ridge post, a post that will carry the load from the roof framing above down to this beam here, and then of course down through some posts to the building foundation. And of course these two walls here will be built exactly the same also, with a window in the center and a 2x4 to help us support the ridge. And in case you're wondering why we don't have a ridge beam here, that's because we're going to be getting the structural support from the bottom of the roof rafters. However, I'm not about to suggest that you wouldn't need a ridge beam here. So contact local building authorities or engineers in your area for clarification before building a project exactly like this. And these walls here again will be the same proportion or the same size and will be supporting the bottom of the roof rafters. And that's the reason why this part of the wall continues through to the outside and not butt up against this wall here. However, I'm not about to suggest that you couldn't have that rake wall go all the way down. And the simple fact that this building is built in sections that have the same proportion and similar measurements will allow you to calculate the measurements for some of these walls a little easier than it would if they were different measurements and different sizes. And this wall right here will not have a hinge point because we are going to have a ceiling joist up against it. However, this is a wall that you could balloon frame and have full length wall framing studs. And I believe this is the only section in the house where that could happen. And the rafters for this section will be sitting on top of this wall framing. Again, we have the same situation here where we're running this wall through to the end so that the rafters can sit on top of it. Next up, let's go ahead and set our roof ridge. We will need a ridge here because we're not going to have the same structural support that we're going to have down here or in this room or this room. Next up, let's go ahead and take a look at the little dormer pop-outs that we're going to have here. And this will be a small section and create some tiny rooms, but definitely add to the nice design of the building. And another thing you should keep in mind that when you do small things like this with a lot of detail, it's going to cost a lot more money on your project. I would imagine if you left both of these dormers out and then just brought the roof down or even set the dormers up a little further, you could definitely reduce the cost of the project. However, how much, I wouldn't be able to provide you with that information, or whether or not it would actually be worth it to do because of the design. A view of how the corner here will connect together. Again, the rake wall is coming down, butting up against the wall that the roof rafters will be sitting on. And of course, without the lower section in the way, some of this stuff is going to be a little easier to see. And of course, that would be my learning curve there. As I do more of this stuff, I can get a better idea of just how confusing it is to see some of this stuff when some of the other framing components are actually in the way. And some of these sections might be a little easier to build after the roof is built. I don't expect you to build this section right here before the roof framing has been installed, but that doesn't mean you can't extend the top plates out a little bit so that they can be cut off later. Main section again, and a view of how this wall is coming out. This one here is butting up against it. And again, there is a beam underneath this wall to support it. And we have a header going over the wall here because the walls aren't very high. I want to say they're about 7 feet, and a regular door might not fit in here. You might need a custom door made for that area, or you would need to raise the wall framing. And of course the wall studs that will be sitting on top of the framing plate below. The ridge beam, a better view of it there. And how it's going to be supported by a post so that we don't need to install a monster-sized beam there. And of course the load from the ridge will transfer straight through and not through the headers. So if we had a header that went all the way across and then a post sitting on top, then the weight would transfer around and not straight through. And of course that could provide you with another design option also. And let's not forget that you might need a ridge beam coming off of both of these points here to the wall here, and then sit on top of a post that would be located in that wall to transfer the load down through the floor framing to the foundation. And in the last section of the video, I'm going to go ahead and remove some more of the framing components so that we can zoom in on some other parts and avoid annoying color changes. And of course that happens, I think, when I get too much stuff in some of these videos. I mean, sometimes I have all the nails for the hangers and then all of the rebar, you name it, and it changes colors while I'm going from scene to scene. And in some of the examples, I'm going to focus in on one part of the house where we have this roof here built pretty much the same as the one in the front. So I'm not going to go around every single part of the building when I think you can get a pretty good idea what the front porch is going to look like by looking at the back one, or what each side of the house will look like. And again, this wall right here is going to be the same as the one on the other side. The front porch is going to be a little longer than the back, and this side is going to be a little different than the other side. But for the most part, this gable end and this gable end, this gable end, this gable end, this dormer and this dormer are going to be the same, along with the same measurements. Let's go ahead and remove the fascia board and then come in on the front corner of the porch here. And in this model, I spaced all of the rafters 16 inches on center and tried to make it work out for the plywood. So I kind of went 16 inches on center all the way through in both directions if I could. Zoom in on this part of the house where we're going to have a full-length rafter and a partial rafter that's going to nail into the wall framing along with our ledger here. This will not be a ridge since it is going to be nailing into a wall. And we are going to be using 2 boards instead of 1 long board for our ridge here, along with shaped blocks over the exterior wall framing. And this building will have a flat soffit all the way around. And you could always install some backing here. I didn't because I wanted to show you something I've done before, and that would be to build this dormer roof over this roof. I'm going to install my sheathing here and then nail the roof sheathing to the bottom of these boards here. I've done that before and nobody's ever had a problem with it. However, if that's not going to work for you, don't do it, of course. And then this roof here will build over this roof. You'll put the roof sheathing on this first, and then build this section of the roof over it, along with your fill rafters, common rafters here. And again, we have 2 boards creating our roof ridge. And I went ahead and left these blocks a little lower, but you're probably going to need perimeter nailing. These blocks will need to go all the way up to the ridge. However, I have seen them lowered before like this when installing ridge vents, something that will allow the air to circulate out of the attic or into the attic through a ventilated ridge that might be made out of metal. I don't think I've ever seen them made out of plastic. And of course our rafters will lap here, and since we are working with a 45-degree angle here, the ends of these rafters will be square on each side, which might make it a little easier to cut the roof rafters. And of course our mid-span blocks that we have here usually go in the middle of the span of the common rafter. And of course our little wacky roof, when I was designing the project, I really didn't understand what I was going to be getting into here. But you can see here where this is going to need a little creative adjustment for the roof sheathing, along with the fascia board. And of course, this section of the roof here took me a little while to design. And this section of the roof is going to sit on top of the lower section, or the porch roof. And be prepared to spend a little bit of time working on this section of the roof if you build a house like this, to get everything to plane in nice and flat all the way around. And of course, the porch rafters will be connecting to the roof rafters here that will be sitting on top of a wall, a short wall. And I would imagine after you finish building something like this, you could consider yourself to be a roof framer. And the porch is going to be a little bit longer in the back, might require larger rafters, and you might need to install larger hips or double up the hips or add some type of structural supports in the areas where the hips are going to be sitting over some type of load-bearing walls. Let's go ahead and zoom in on the upper connection for the hip. It's going to be sitting on top of the wall framing plates, and the roof rafters will be sitting on top of our stem wall or short wall here. And the porch rafters that are not going to be connecting to the hip will be lapping and connecting to the roof rafters. And in this section here, they will be sitting on top of the wall framing also. Take a look at the ceiling backing there. And the ceiling backing is going to go all the way around the rake wall here. Next up, let's go ahead and take a look at the dormer. We're going to need a doubler or a beam here, along with a doubler on each side of the supporting beam. This beam is going to be supporting a section of the dormer and might require some type of structural engineering. Keep in mind that I'm not a structural engineer, and before building something like this, you should contact somebody to provide you with the correct lumber sizes for your area. Another view of the lower connection there for the rafters. A view of the porch framing here. Ceiling joist here, right here, and then our porch rafters here going up to the ledger. Ledger is going to attach to the wall framing. A view of our double windows there. And I'm sure I drew my ceiling backing in there somewhere. It just disappeared. Let's go ahead and add our fascia board and then zoom in on a couple of sections where the fascia board goes over the roof sheathing. You're going to need to have a gap here to allow for the roof shingles to slide underneath the fascia board. If you don't, the roofer won't be happy. And then a view of the corner here. You've got to make sure that wherever you need the roof shingles to go under, that you have enough space for them. An example of how the porch roof is going to die into the upper roof. And I think this roof here is a 2-in-12. Don't quote me on that. And at the other side, again, we have the gap for the roof shingles. How our wacky section here is going to die in. And let's go ahead and wrap this video up with 2 more pictures, and that is it. A nice upper view of the roof with a longer roof in the back, shorter one in the front. And if you want to save some money, get rid of this thing right here and get rid of the 2 dormers here.